Hi everyone, welcome to EIA2011 Introduction to Computer Assistant Data Analysis presentation. We are group 2.6 and today we are excited to share our assignment 1 with you. First, let me introduce our group member. Our group leader is Wong XIAN and the other members are Sao XUAN, BOON, LIEW, HENG, yeah, that is me, Ying, and Daya. Now, let's move on to the next part, the scenario. Scenario is about Dr. Elise is currently teaching a Bachelor of Economics course with a cohort of 300 students. She conducted a 5-question survey which all her students completed. The survey included the following question. Question number 1, what is your age? Question number 2, what is your sex? Question number 3, are you a local student or an international student? Question number 4, what is your primary mode of transport used to get to class? Question number 5, if you were allowed to ask one question about our class, what will your inquiry be about? This is our scenario.
Thank you, Yuheng, for that wonderful introduction. Now let's move on to question 1. Based on the responses collected, describe Dr. Eilish's students in terms of their age, sex, student type, and primary mode of transport. As we can see, the primary Excel function that we use is COUNTIF. COUNTIF requires two main variables. One is the range of the dataset and the criteria which you want to count with. For example, as we said just now, we wanted to find age. So, how do we divide them based on age? We could equals COUNTIF, then type the range set to the dataset, and the criteria set into individual ages such as 18, 19, 20, 21, 22. And as you can see, the function successfully counts the amount of students that belong to the particular age group. And we can use some function to make sure that the total amount of students equals to the amount we counted in the frequency, so that we don't have any missing data. We can also transfer this table that we calculated into a graphical form, such as a column graph. As you can see, most students belong to the 19 years old, 21 years old, and 23 years old age group respectively. Moving on to another set of data, we could, the same set of data, but a different type of way we can calculate. We can look at sex, and we can use the same function, but instead we could change the range to check what gender they are, and as well the criteria set to male and female. And we can see 51% of the total student population are female, while 49% represents the male gender. Besides that, we could also find the type of student. In our survey, we have two different types of students. One are local students, second international. You can see local students make up an overwhelming majority with 93% of the student population, whilst international students only make up 7%. We also conducted the primary mode of transport based on the survey. So we can see that more than 50% of 152 out of 300 students drive to school every day. Besides, the second most popular option is motorcycles. So meaning that personal vehicles are an important factor in students making their modes of transport. So now I will pass on the mic to the next speaker. Thank you.
And we will move on to question 2. If there are 7 students in class, what is the probability that exactly 4 of them will inquire about the quiz? And we'll use the data set to determine the relevant probability distribution. And last but not least, we will create a visualization about the probability for different number of students, which is from 0 to 7. So the first step is we will count the number of quiz-related inquiries. So from here, we'll use the COUNTIF formula, and we will select the data from E2, which is the first data, until the last data, which is on E301, and the related inquiries is quiz, so there is a quiz there, and the number is 145, and the total student population is 300, and the probability we will calculate by 145 divided by 300, and we will get 0.483. So the second step, we will calculate the probability of exactly 4 students out of 7 inquiries about the quiz. So the total student here is 7. Quiz inquiry probability is 0.483, and the exactly number of quiz inquiries is 4. So here we will use the binomial distribution formula. C20 is 4, C17 is 7, and then the C18, which is equal to C12, which is 0.483, and here we will select false, and the probability of exactly 4 out of 7 students inquiring about the quiz is 0.263.
So moving on to step 3, now I will talk about the probabilities for different numbers of students from 0 to 7 inquiring about the quiz. So before we answer the questions, we need to form a table first, including 3 columns and 8 rows. The title of the table is numbers of students, probability, and also probability for the line. Why I want to create 2 probability? This is because after that we need to plot a graph, so the binomial distributions, including the histogram and also the line. So we need to create 1 column for the histogram and also 1 column for the line. So we need to create 2 lah. After that, you just type from 0 to 7 in the number of students and starting calculate the probability by using the binomial distribution equation. First of all, type the equal first and also binomial dot distribution bracket P33. P33 means the smaller n. It depends on the number of students. And comma C15. C15 is the larger of the n, which means is 7 in this case. And comma C16. C16 means the probability of success, which means is 0.483 and also comma false. False means the exactly amount of the number of students, means not the cumulative one, not the cumulative one. It's the exactly amount of number of students. And after that, close the bracket and enter it. You will get the probability, which is 0.01. Then you just double click on the border of the box. Then you will get all the probability from 0 to 7. So we will move to the graph. The graph is binomial distribution of students inquiring to the quiz. So as you can see, the graph is like going up at the beginning and stop at the middle and going down at the end. That's called binomial distribution. So as you can see, the probability to get 0 students inquired to take the quiz is 0.1, and the probability to get 1 student inquired to take the quiz is 0.064, and the probability of 2 students inquired to take the quiz is 0.181, and the probability of 3 students is 0.282, and the probability of 4 students is 0.263, and the probability of 5 students is 0.148, and the probability of 6 students is 0.046, and the probability of 7 students is 0.06. So as you can see, the highest one is the number of 3 students inquired to take the quiz, which is 0.282, and the lowest probability is the number of 7 students, which is 0.06. So that's all for question 2.
Now, I'll continue with the third questions. For the third questions, it is about the Poisson distribution. We need to find out the probability that Dr. Alish will receive at least 4 questions in the next sessions. So, first step, we need to let X equal to the number of questions from students during class sessions. As the question mentioned that, on average, Dr. Alish received 8 questions from students during a class sessions. So, the average of X in Poisson distribution is 8. Step 2, we calculate cumulative probability using Poisson distribution functions from n equals to 0 until 20. After getting the calculations, we can start to calculate the probability that Dr. Alish will receive at least 4 questions in the next sessions. From that, we use 1 minus probability that Dr. Alish will receive less than or equal to 3, which is 0.042. Finally, we will get 0.958. For the graph part, the distribution peaks at 8 questions, reflecting the average given by the questions. This is the most likely number of questions Dr. Alish will receive in the sessions. For the blue region, it shows the cumulative probability of receiving fewer than 4 questions, which is relatively low, as most probabilities are concentrated near it.
So I'll be talking about the conclusion. So the assignment focuses on statistical and computational analysis in 3 main questions. So question 1 uses the countif function to count data entries based on given criteria. In question 2, involves calculating probabilities related to students asking quiz-related questions. It includes counting the inquiries, finding the probability exactly for students asking, and calculating probabilities for different numbers of students ranging from 0 to 7. Then when we go into question 3, question 3 uses a Poisson distribution which acts in Poisson 8 to model the number of questions students ask during the class. The Poisson dot distribution function is applied to compute cumulative probabilities, showing that the probability of receiving at least 4 questions is P in the X more than 4 is equals to 0.958. This thus demonstrates practical applications of statistical tools to analyze real-world scenarios.